You have fallen into Event Horizon with John Michael Godier. John is joined today by Professor Adam Frank. Professor Adam Frank received his PhD in physics in 1992 from the University of Washington. In 1995, he was awarded a Hubble Fellowship. He joined the University of Rochester as an assistant professor of physics and astronomy in 1996. He was promoted to associate professor in 2000 and to professor in 2004. Professor Frank's research is in the general area of theoretical astrophysics, and in particular, the hydrodynamic and magnetohydrodynamic evolution of matter ejected from stars. He is the author of 3 books, most recently, Light of the Stars, Alien Worlds, and The Fate of the Earth.
Adam Frank, welcome back to the program.
It is great to be back and talking with you guys again.
Now, in your new book, you go into first your own story and how you became interested in astrobiology. And this is something that happened to me too. I remember in the 1980s, I was just looking at the stars blazing overhead as a 10-year-old, around about 1984, 85, and wondering, is there anybody out there? And I still have not answered this question, and none of us have. So give us a sort of a feel for what drove Adam Frank to look and think on the concept of alien life.
Well, I've been thinking about it, since I was 5 years old. And the reason why I wrote this book, the Little Book of Aliens, was to be able to kind of give people a sense of how far we've come from when I was a kid. So for me, it began when I was 5 years old, literally, because I wandered into my dad's office, and in his library on the lower shelf where I could reach, he had all of his 1960s pulp sci-fi magazines, like Isaac Asimov's Astounding Stories. And I remember looking at those covers with their bug-eyed monsters and guys in spacesuits and alien landscapes. And I was stunned. I was like, this is it. This is all I want to know about. And so it's very clear at that moment. And, my dad was a writer, but he was really into science and science fiction. So he saw my interest and he took me to, the Hayden Planetarium, the planetarium in New York City, regularly, much to the chagrin of my sister. But, and he also fed me a steady diet of science fiction, of great science fiction. He would put in my hands, Dune long before I was really ready for it. Isaac Asimov stories. I remember him waking me up one night to watch late night TV. This was back in the 70s. And we watched Forbidden Planet together, right? With its vision of a advanced alien civilization that had disappeared because of their own folly. So this question has just been with me since I was a kid. And then when I entered graduate school and, became an astronomer, it never left. I didn't work in SETI, and we can talk about why, but I never lost the interest in the question. And then in this modern era, as the exoplanet revolution began and astrobiology really became a going concern, about 10, 15 years ago, I started my own research program in it. And now pretty much it's almost all I do.
I had a similar experience. My dad was an engineer, and I loved sci-fi, and he was sticking all the books and everything, and along with my mother, who was an amateur geologist. We were sticking all the books in my hands, and I was reading everything I could and watching reruns of Captain Kirk and all of that in the mid-1980s. And that really served to make me wonder. But the thing is that how far we've come. We didn't even know exoplanets existed back then.
Right.
It was still an open question. Now we have thousands and thousands of confirmed exoplanets. They're ubiquitous. They're everywhere, which ticks a box for life in the universe. The question is why don't we see an example of a biosphere from a distance? And why is it so ambiguous? So ambiguity in the question of aliens, how are we going to deal with this? How do we proceed with things like the James Webb Space Telescope and characterizing exoplanet atmospheres? How are we going to nail this down?
Yeah, well, the interesting thing is about why haven't we seen any evidence yet? Is because we couldn't look. I mean, that's really the basic we only, gained the capacity to look like a few months ago on some level, right? First of all, for most of astronomical history, we didn't even know whether there were any planets to look for, and we believe planets are the basis of life, that you need a surface in order to get have a puddle of water or something to have the chemistry get going, the biochemistry get going. We didn't know whether there were any planets until 1995. That's when we discover our first exoplanet. And then we start building up this census of exoplanets. That took some time. But really the most important thing is that in order to find a biosphere, you have to be able to see the planet in a way that, these planets are, of course, light years away, tens, hundreds of light years away. You need to be able to somehow, through the light, the imprints in the light, be able to get an indication, signature, that there is a biosphere there. And literally, we haven't had the telescopes to do that until, on some level, the JWST. The JWST is the first telescope that can do this process of that we call atmospheric characterization. And even JWST is right on the hairy edge. Like it probably does not have what we need to see a biosphere unless we get really, really lucky. But it is the first one that has really what we need on any level at all. And then the telescopes that are going to follow it in the next 10, 20, 30 years are really going to have, they're going to be tuned. So what comes after the JWST, the next big telescope of this space telescope is already, what is it called? It's called the Habitable Worlds Observatory. Like astronomy is now all in, and that $1 zillion telescope is going to be tuned to be able to find what we call biosignatures. Or if we're looking for technological life, if we're looking for life that, has industry, that harvests energy for to do things for civilization, what we call technosignatures. So we finally, we couldn't do it before because we couldn't do it before.
Now, in regards to looking at radio, the radio astronomers, now they're in a better position because the radio telescopes have been capable of picking up alien signals, the WOW signal, things like that for many decades earlier than optical astronomy or infrared astronomy. So how in depth have they actually looked in radio? For example, the bathtub, of the ocean. So what is our survey of looking at star systems, looking for radio signals? It seems to me we've barely just started still. Is that a good sense of that?
Yeah, that's a great way of characterizing it. I mean, so I think people have to understand that what I call classic SETI, right? The classic SETI searches where you're using radio. And in particular, in the beginning, people were really using radio to detect a beacon, a signal that somebody was purposely, putting out that was aimed at you. Right. And they had to make these assumptions because if you didn't do that, if you assumed that they were just, broadcasting in all directions, then you ended up needing a transmitter that was so powerful it was almost a star. So there was this, underlying the kind of technologies we had, you needed somebody to be beaming a message at you. So I'll talk a little bit about that later. Why, for me, that was always a little bit problematic. But it was also the only thing they could do, so it was fine. But people also have this idea that Frank Drake did the first search of this kind, classic SETI search in 1960. And since then, well, of course, we've searched the whole sky and we haven't found anything. So, where are they? It must be that there's no alien life. And the problem is with that is it's not true. And it's not true for the saddest of sad reasons. There has never been a lot of SETI searching because there was never money for SETI searching. So, because of the giggle factor, and we can talk about what the giggle factor is, but because SETI got associated with UFOs and little green men, it was always looked upon, it was always a little marginal, more than a little marginal. And so the pioneers of SETI, who were very, very brave scientists, had to put up with a lot of scorn, and also there was just never any funding. So if you think of, if you want to add up all the SETI searches that have ever been done, all the time somebody searched a star for signals of intelligent life. So imagine that the stars are, the sky is an ocean, right? And you have to search that ocean. If you add them all up, how much of the ocean has been looked at? And the answer turns out to be a hot tub. Basically, we've looked at a hot tub worth of the ocean, and we didn't find any fish, so to speak. And are you then going to say, like, well, there's no fish in the ocean? So, the fact is we've just never searched, right? There's, other than a few brave pioneers, there never has been much SETI searching. So, the claim that, we've looked and we haven't found is just the idea of a great silence. There is no great silence because nobody's had the funding to listen. So, so I think that's a really important thing for people to understand, because now finally, not only with radio, but more so this explosion of what has happened in what I call, I think the whole field should be called techno-signatures, and SETI is just one part of it. With techno-signatures, this field, we are going to be looking. We finally have the funding to start looking for biosignatures and techno-signatures. And, NASA's all in on it. The astronomical community is all in on the search for life in the universe. And so finally now we're going to start looking.
It should not be surprising if we find it, though, because one of the things that bothers me is that you'll get a lot of people saying, well, we're alone. The problem with that is that you can't ever prove in the universe that you're alone. You can only prove that you're not alone by picking up some sort of a technosignature. So, but if you're going to start saying that life on Earth only happened here, then you're saying that an organic chemical process, which is what life ultimately is unique to Earth. Mm-hmm. And this is a problem. And that gets into the scorn factor, in that we should statistically be part of a population, right? In other words, we should expect to find a technosignature eventually, right?
Well, I think, it's funny because as I talk about in the book, right, so much of the book is about sort of the balance between alien optimists and alien pessimists. So the book starts with the history, right, which begins, 2,500 years ago. It's amazing how long people have been asking this question. With sort of the battle between Aristotle, who was a pessimist, who said the Earth is the only planet in the universe that has life, and Democritus, who was an atomist, who said, no, every star is going to have planets, and every planet has the possibility for life. So that battle has been going on for a long time. And what's remarkable now is, over the entire history, that 2,500-year history, it's been just about opinions, right? There was no data. And so what's amazing now is we're about to get data. Now, I am an optimist, but I also, let's unpack this a little bit, right? Because you look at the night sky and you look at all the exoplanets, and, you're sort of overwhelmed. In that paper I wrote with Woody Sullivan back in 2016, where we worked out how many habitable zone planets there were in the universe, it turns out to be 10 billion trillion planets. And each one of those planets is an experiment, right? Nature has run the experiment in life and possibly civilizations. So it's asking a lot to say that every one of those experiments failed, right? But the problem is, until, we don't really know yet what goes into making life or allowing life to thrive so that you get a biosphere or eventually a technosphere. So if there are 10 billion trillion habitable zone planets, and that's not an inhabited planet, that's a planet where life, where liquid water could form on the surface. If the odds per planet is less than 1 in 10 billion trillion, then you've just run out of planets, right? It's a kind of a probabilistic thing. Now, I don't think that's the case, right? But it's really still my opinion that that's not the case. So the statistics alone, while for you and I probably make us lean in the direction of there's got to be life elsewhere, until you do the search, you just don't know. And that's what's so exciting. That's why I wrote this book, is I wanted people to see, finally, right? Finally, we're going to start getting data. And one last point on this, along these lines, while you can never prove there's no other life, if you can start putting upper limits, or limits on it, right? If we search for 100 years and we search thousands of stars and we don't find any, that's at least beginning to tell us that, okay, we can't prove there's no other life out there, but we are beginning to prove that it's rare, right? So that's what we'll see.
Now, in regards to thinking about alien life and thinking about what we might look for, and there's no guarantee that technological alien civilizations look like what we think they will, They may be indistinguishable from nature for all we know. But things like the Kardashev scale and the Drake equation, do you think they're getting long in the tooth and that we need to rethink just how we look for aliens?
That is a great question. And I think that is what's so exciting about this moment. Because when you look at all of astrobiology, which used to be called exobiology, and the thinking about life in the universe, I'm actually working on a New York Times op-ed on this, exactly this point. We've always, or almost always, began with the terrestrial analog, right? We just tended to think that life, whether it's smart life or dumb life, right? So when I make that distinction, dumb life, I do not mean any disrespect, is microbial or forests. It's the stuff that doesn't build civilizations. It's very sophisticated, right? But I'm just going to use that distinction. Whether people were thinking about dumb or smart life, they just tended to sort of use Earth life as the example and the template. And I think one of the most exciting things that is happening now, and I talk about this in the book, is because we're finally really committing, the scientific community is committing to this search, we're starting to systematize, right? We're starting to look at our ideas and really say, like, wait a minute, right? We don't want to get mistaken by the very particular history of Earth's biological lineage. So what you see a number of people doing in our group. So, I am the principal investigator of NASA's first grant to look for technosignatures. What everybody's beginning to do is think agnostically. What does it mean to plan a search that is agnostic about the life that you find, right? You're not expecting it to be carbon-based. You're not expecting it to have DNA. If it's a civilization, you're not expecting the minds which built the civilization to use integers as the basis of their mathematics. So that's the really exciting thing now. And it really stretches, the fun part is it really stretches the imagination. And so in the book, I'm trying to give people some understanding of what this agnostic thinking looks like, because that's going to be the best bet at making of whether we find, looking for biospheres or technospheres.
The problem of habitable zones as we see them, we think in terms of liquid water on the surface of a planet that's essentially an analog of Earth. But we have found from our own solar system that ice shells over oceans is more common. So do you think that what the real solution to the Fermi paradox is that most intelligent life is locked under ice and completely unaware of the cosmos because I can't see it?
Yeah.
Now,
yeah.
Is that a good direction to go? But the thing is, do we have any hope of ever detecting intelligence under an ice shell moon outside of our own solar system?
No. Well, not at least right now. I mean, that's, in some sense, it's true. The habitable zone was a great idea, right? It's one of those classic ideas. In the book, I talk about how that era of the 1950s, from 1950 to 1960, that so much amazing foundational ideas were laid down, right? And no matter how you're interested in life in the universe, you got to pay attention to that decade, even for the pop culture stuff that got laid down. So the habitable zone, which is the idea that life will need water to get started, was a great idea because there really is reasons to think that water is pretty amazing as a solvent. But as we've seen from our own solar system, as you point out, we've got at least 2 or 3 or 4 other places where there are oceans, huge oceans, more water than on Earth, underneath underneath moons, with, like you said, ice-covered moons. But as you say, the problem is that if a civilization develops under those or in those, that we'd never know. Or even if there's intelligence, even a biosphere under those worlds, we would never know. So I think we just, if we're looking for life at this point on distant worlds, we have to be shooting for the stuff on worlds that will have that have detectable biosignatures. So that's a subset, and maybe we're going to end up missing the boat because of that. But you can only look where you can look, right? It's the analogy of the keys under the lamppost. I mean, beginning, that's where you look. You look for the keys under your lamppost, and if you don't find them, then you try and be more ingenious about how to look, in the dark.
If we want to answer the ice shell question, we're just going to have to conquer the galaxy. It's simple as that. It's the only way
That's the only, I agree. We should get started, start building those, those starships now, build the Battlestar Galactica now, and then we'll be ready. Then we can,
Then we can start, thinking about it. Now, rogue planets. So this galaxy can sit here and toss out rogue planets, Earth-like planets that are covered in ice again, but with geothermal energy, they may maintain oceans. And that opens up the idea of intergalactic inhabited planets that, I mean, how would we ever? Then that gets into not being able to prove that you're alone again. In other words, unless you detect a technosignature, you're not going to find a way to know if there is other life in the universe, because it's just not going to present itself, and you can never know. So the only thing we can do is look for technosignatures, essentially, right? And biosignatures to an extent, but that's, getting close. What is the distance limit? In other words, all right, so we're looking for technosignatures in whatever form they might be, Arnold louvers or radio signals, whatever. How far can we look, even just within the Milky Way?
Before I answer that, I just want to talk about how cool rogue planets are. Because if you're a space pirate, like, where else do you want to be based but on a rogue planet, So I love the idea of rogue planets. But it's a good question, right? We're not going to, especially now, just to your point, though, I'm not sure if rogue planets could be intergalactic, because I don't think you'd have to toss a planet out with an escape velocity to get it out of the actual gravitational well of the galaxy. So I have a feeling that might happen once or twice. I don't know. But I have a feeling that most rogue planets will be interstellar, not intergalactic. But that'd be an interesting calculation to do, whether or not you could ever get the escape velocity to actually...
Well, I think another question would be is if you toss out a star system, does its planets go with it? I would assume that they would.
I think it is. I think I've seen papers on that. I think that the planets in general do get, unless it's super duper violent, you'd have to really accelerate a star super fast to unbind its planets. So I think that, but don't hold me to that.
Would life survive an encounter at the center of a galaxy with a supermassive black hole in that radiation environment? And there's lots of questions, because tossing planets out, that's a
yeah, it's a whole other
animal.
But to your question of distance, right now, right, it all depends on the technology you have. And so right now, I'm sort of making an educated guess. I think we're really talking about, if we're talking about the method of atmospheric characterization, which we can unpack more, but, just to sum up, atmospheric characterization is the ability to peer into a planet's atmosphere and detect signatures in the light, like use the light that passes through the atmosphere to look for fingerprints of either biology, of a biosphere, or technology, a technosphere. And I think the limits are hundreds of light years. I don't think you're going to be able, at this point, you're not going to be able to get to thousands and thousands of light years. And the reason for that is you just need a lot of photons. You need a lot of light to be able to get a really good spectra, to be able to have enough light that you can break it up and look at the different wavelengths of light. You need a lot of signal, basically. And to get a lot of signal, you need to capture a lot of photons. And to capture a lot of photons, you're a lot better off if the thing is closer. So I think the next 30 years or so, and some, maybe one of your listeners who knows more about this than I do, another astronomer, I think we're looking at hundreds to 1,000 light years, which is the neighborhood, right? Which is that is just down the street, so to speak, for the galaxy.
Yeah, that brings into interesting scenarios, because anybody in the galaxy that's doing what we're doing and looking, the vast majority of the galaxy, basically all of it past, around about 100 light years, has no idea we're even here, other than if they've looked for biosignatures on this planet. Well,
I do, with bigger telescopes, you can go farther. At some point, hopefully, if we make it through all the mess that we're in right now, from possible nuclear war to climate change, and maybe even AI, who knows? But then, at some point, we may build telescopes that are huge. We could build interferometers in space that would be able to see out thousands or 10,000. So right now, this is just a technological limitation of our age. A civilization that's more advanced than us, and I'm even talking 100 years, 200, 500 years, would probably be able to detect biosignatures, across much further, maybe even, tens of thousands of light years.
An alien civilization that has an interferometer or such, telescope that, is the size of New Jersey in orbit, and looking at the Milky Way galaxy, trying to characterize its exoplanets several million years ago, knows about this planet. In other words, this planet has been screaming its biosignatures for billions of years.
Billions of years.
Our planet has
amazing.
betrayed us. We can't keep quiet, at least about the biosphere here. So chances are that while we may be ignorant still on the question of alien biospheres, it is possible that someone else in the galaxy confirmed and answered their "Are we alone?" question by looking at Earth. Is that viable?
I think that's, I mean, what reason would you have to not consider that possibility, right? You have to really have, and this is the interesting thing in this moment that we're in, where, as I said, so there was this long history of the giggle factor, that any mention of particularly intelligent, like the search for intelligent life, civilizations, was met with raised eyebrows and, a snicker. And, this was again because of the association with UFOs. And what happened in particular was in NASA was a couple times in the 80s and 90s, NASA tried to fund some SETI projects. And then some congressman would stand up and be like, we're not going to waste taxpayers' dollars on searches for little green men, and the funding would get cut. And of course, this was like less than a drop in the bucket of the budget, even NASA's budget. But, they were making hay. They were getting some political points out of it. So NASA was like, oh, okay, we are just not touching this. This is a red hot chili pepper, and we are not touching this. And so, the whole search kind of went by the wayside. But now, it just, as you're talking about, as you're bringing up, why wouldn't we begin to, now we know that we could see biosignatures from a distance. And here's the interesting thing. What would happen if we found a planet with biosignatures? Let's say like 10 years from now, the next space telescope detects like a beautiful, it's oxygen and methane and sulfur, SMS, oh God, my brain isn't working right now. The stuff that plankton put out, it'll come back to me in a second. These are all good biospheres. If you found biosignatures, sulfur, dimethyl sulfide. That's what it is, dimethyl sulfide. And if we found really good evidence of a biosphere, what would we do? We would, keep watching. We'd build an even bigger telescope. We'd build an even bigger telescope. And at some point, we'd send a probe, right? We'd send a robot probe. If it was close enough, let's say it was, within 10 light years, if humanity makes it, we would figure out how to, shoot a probe there. And then we do another one and another one after that and another one after that. So, at that point you realize like, wow, if we have been screaming our biospheres or our biosignatures to the galaxy for 3.5 billion years, then suddenly solar system SETI, as they call it, begins to make sense. Like maybe we should be looking in the solar system for somebody that came through 2 billion years ago, sent a probe, and now the probe is just tumbling around somewhere in some orbit, or something, somebody dropped something on the moon and, they set up a base, and again, these would probably be robots, set up a base to look, to probe Earth's biosphere and send information back. And that's one, I'm doing a project right now with a couple of other people where we're trying to calculate how long the lunar lander is going to be visible, right? And we're using the lunar lander as a proxy for somebody came by 1 billion years ago, dropped a probe on the moon, and there's no weather on the moon. There's only the, what they call gardening from micrometeorites. But yeah, how long would that actually last? So should we go look for them on places like the moon?
Oh, of course, because it's as you said, it's like a locker, where things can survive billions of years. They can just sit there. But another interesting one that's always intrigued me is the idea of, as we study asteroids, finding one that's really depleted, as though it's been mined.
Yeah. Right. That's been mined.
By a passing
right.
von Neumann probe, or you remember Arthur C. Clarke's Rama novels where some.
Oh my God, one of my favorite stories.
So some von Neumann probe passes through 1 billion years ago, doesn't care about Earth. It's just looking for raw materials from an asteroid so it can go to the next star system. And then we find it, and there it is. That's not a very well talked about technosignature, but depleted asteroids is interesting. The question is how many do you have to look at?
Right. But the idea of solar system SETI is gaining some momentum. The more people are talking about it, and it's sort of like, what you need is once your civilization starts doing it, right? Then you're like, once we do it, then it's like, okay, well, we have one example of this happening. Why wouldn't we think that it's possible for others to do it? The group did a paper, Jason Wright led it, where we examined the idea of, okay, what do you think you're going to find first, a biosignature or a technosignature? And, there's this assumption, this bias that, biosignatures are going to be more common than technosignatures. But really, that is just a bias. And the reason we think that is because, you need a biosphere before you make a technosignature. That's true. But once you make a technosphere, then the interesting difference between them is biospheres can die, right? And when a biosphere dies, the biosignatures die with it. A technosphere can die, but if you've put out a bunch of space probes, then its technospheres continue living on. We already have we have 5 technosignatures, meaning space probes that have already left the solar system, right? Now, nobody's it's going to be very hard to find those because they have very weak radio transmissions. But there it is. There's proof of principles. There are biosignatures, artifacts that are already leaving the solar system from Earth's technosphere. Mars has a bunch of Earth's technosignatures on it. And biospheres, you'll never get a biosignature that's left the biosphere. Technosignatures can leave the technosphere and go create other technospheres, or just travel from place to place. So on some level, you might expect that technospheres are going to be the first thing you're going to find. Now, I'm not sure if that's true, and I'm not going to put my money down anywhere, but it really argues that you need to be searching for both biosignatures and technosignatures. You shouldn't put your eggs in either basket.
Modeling the expansion of an alien civilization, say someone else arose, many millions of years before we did, and has started to colonize the galaxy. It seems that once you start, it seems to, and I know you've done work in this, it seems to exponentially go, and we really should be seeing alien civilizations, right? In other words, the Great Silence really should not be, because once you get to a certain level of technology, you can colonize the galaxy, and it would take you millions of years. But if you have millions of years, then there you go at sublight speeds. So does the fact that we don't see aliens everywhere, which is what I think Enrico Fermi asked, is, does that seem strange to you?
Well, Enrico Fermi did not ask, do we see them everywhere? He wanted to know, why don't we see them here now? Right. And if you're into UFOs, you'd be like, they are here now. But, if you're not into UFOs, you're like, no, they're not here now. And I'm not really wildly bothered by that, what I call the direct Fermi paradox. The direct Fermi paradox is, how come they haven't landed on, Earth, or landed in Washington or Paris and announced themselves? And I'm not bothered by that for a number of reasons. First of all, when did they land? Right? As we showed, Gavin Schmidt and I showed in that paper back in 2018, if there was a dinosaur civilization on Earth 500 million years ago or 100 million years ago, there'd be zero evidence of it anymore, because the Earth gets resurfaced every couple of million years. That's all it takes. So there'd be no physical evidence of a species, of a civilization that could have been here for 10,000 years, right? So, you have to think about time as well as space. So when did they arrive? And unless they live forever, and civilizations in general don't live forever, then they wouldn't be around anymore. And so when in that work we did, so Jonathan Carroll and I and Jason Wright, we did simulations of this, and it is absolutely true that the expansion wave, once it gets started, will cross the galaxy pretty quick. Civilization can hop from one place to the other pretty quickly on the timescale of the evolution of the galaxy. But if you allow civilizations to die, then you actually can end up with holes in the where there just is nobody for a few million years or hundreds of millions of years. And in that case, then, yeah, maybe that's where we're living. We're living in a hole. Nobody's, maybe somebody visited 3 billion years ago, but there's no evidence of that. And right now we're just living in a hole that's not particularly deeply colonized. Now, the other part about why don't we see them, that's what we talked about before, what I call the indirect Fermi paradox. And that's because we haven't looked, right? We just haven't looked. So why aren't they here? I think there's pretty reasonable answers for why we don't see aliens here right now. And then why haven't we seen them elsewhere is because we haven't looked.
The UFO phenomenon, which is undoubtedly going to come up in the comments, is, the problem is that it is really ambiguous. There's no landing on the White House lawn or anything like that. But
right,
it does deserve attention because, we'd be really stupid if we're looking for alien life and we missed that, if that's what that is.
Yeah, so that would be bad.
That would be bad. So what are your views on that? Do you think that we really need to take a very serious look at the UFO phenomenon and get rid of the stigma that surrounds it?
Well, I think it's good that the pilots in particular, feel free to, now there's less stigma for them reporting. And I'm all for the NASA panel that is going to do the investigation, most of all because people are really interested. So, for that reason. But, what I will say, so, there's a nuanced answer here. The first answer is there is no evidence, hard evidence, the kind of evidence that I would be required to produce if I claimed that I found life on an alien planet. There is no evidence in existence that links UFOs or UAPs to alien life, right? So let's think about the kind of evidence we have. It's a lot of blurry photographs. It's a lot of stories, narratives, even by people you trust, but they're still stories. And then you get reports of radar detections, right? But none of these are the kinds of evidence that I would be required by my colleagues to produce if I said that I had found alien life. And so let's go through this a little bit and think about it, right? So personal testimony is just, there's nothing you can do with science can't do anything with personal testimony, right? We know for sure that personal testimony is the worst kind of evidence. Even people who are reporting in good faith, memory is not a record. Memory is easily confused. Memory is, distorted. It's just not a good report. If somebody says, I saw something move faster than an airplane can move, okay, what speed are you talking about? I made an estimate. That's not what you're going to be able to need to be able to say, like, oh, that was actually moving in a way that a terrestrial spacecraft couldn't move. Then you get these images, right? And the thing that really I always want to emphasize is that, the images have not improved in quality in, 70 years, even though photographic technology has exponentially increased. It's always fuzzy blobs because people send me pictures, right? And they were like, well, what about this? And it's like, oh, another fuzzy blob. Even the stuff on the Navy videos were fuzzy blobs. And I want to compare that to the Chinese spy balloon. There was this image that the pilot of the U-2 spy plane, or the U-2, I think that's what it was. But the pilot, basically, it looks like he literally is holding up a cell phone and taking a selfie because you can see the reflection of his helmet in it. And you can see the spy balloon, right? And the image is so clear that you can make out the rivets on the solar panels beneath the payload, right? And if, the sky was full of UFOs and amazing aircraft, we'd have infinite numbers of images like that, and we just don't. And then finally, there's the radars, which is like, look, if you want to do science, you need to know what your instrument is. Having somebody tell me, yeah, we saw it on radar, is not the same as saying, like, okay, show me the radar, show me its history, let me take it apart to make sure that it doesn't have kind of glitches it has. There's been some really great sort of reporting or stories by Phil Metzger, who's a astro engineer, about how he for years he worked with radar. Worked on various radar systems for NASA, and he talks about all the glitches, all the phantom reports, all the problems with radar. So the answer, so the emphasis on we just don't have any kind of data yet that would link these sightings to any reason why we would think they have any kind of really crazy performance characteristics that are linked to aliens. But I'm all in favor of doing the science. And there's a bunch of chapters in the book that talk about UFOs and UAPs. And there's a whole chapter on what would you need to actually carry out a true, open, transparent scientific search of UFOs and UAPs, which I'm in favor of.
As am I, and the book covers that actually quite well. And that was one of the things that impressed me, is that you're not afraid as a scientist to say UFO.
Right.
And yeah, which is important. That's the first step, because in the past, there have been scientists that got pilloried. James McDonald, J. Allen Hynek, and people like that looked into it and said, there might be something here. And ended up by that same sort of machine in Congress, actually, to, shut it down and ridicule it. Little green men and things like that. But again, I don't like the idea of sitting here saying, well, this civilization that's surrounding us is unique. There are no others. There's no way you could ever. That's actually the more preposterous claim, is that we are alone. And, shouldn't we assume that we're not?
I don't think we should assume that we're not, because I can actually imagine a bunch of ways that we are. Because even if, let's imagine that the universe is constantly popping off civilizations. But look at our civilization. It's a little questionable about how long we're going to last. It's not entirely clear to me that, 200 years, 500 years from now, this kind of high-tech, global, spacefaring civilization is still going to be here and intact. So imagine you're constantly spinning off civilizations, but none of them last more than 1,000 years. Then you just don't overlap. At the moment if that's true, then at the moment we're looking, there's nobody out there. Also, it's possible that that civilizations are just hard to make. That intelligence of this kind of intelligence is hard to make. I mean, you look at Earth's history, and microbes appeared immediately, and technological civilization took another 3.8 or whatever, 3.5 billion years. So I agree with you. I am an optimist about this, but I can certainly imagine ways in which, it's hard to make long-lived technological civilizations.
Looking for the trash of past extinct civilizations is another form of a technosignature. So if it really is a situation where it's ships passing in the night, but not quite, rather it's ships passing a billion years apart, a civilization pops up in the Milky Way, goes extinct, and it doesn't see another civilization for a billion years, then it should be no surprise that we don't find anything. But at the same time, we shouldn't be surprised if we find an artifact. We find the space jockey from Alien, and we're like,
right.
Yeah, so we're sitting here. I wish they would have left. I wish Ridley Scott would have left that a mystery, and that we just.
I know the unpacking. I know all the new parts of that franchise. I'm like, meh. The first two were so good, and then almost everything afterwards got stupid.
It needed the mystery.
Yeah,
and just coming out of nowhere, finding the space jockey while you're fighting a xenomorph, and then you find this ancient alien spacecraft. it just.
That was great.
That was great, but then we found out how the sausage was made in later movies. But but that idea, though, of looking for defunct equipment from a past civilization just cook into the solar system. So is that another way that we could do it, rather than, of course, looking on the moon and Mars and, looking for things preserved there, but just moving through the solar system in, that style of Oumuamua that might be a perfectly valid way to look for a technosignature, right?
Yeah, but actually we don't even have to do it in our own solar system. I mean, the nice thing again about technosignatures as opposed to biosignatures is that exactly technosignatures will, certain forms that you can imagine will be long-lived. So we're working on a paper now. We have this idea of service worlds, right? That if you're a civilization and you got a nice habitable planet, and there's other planets or moons in your system that are barren, like the moon or Mercury, or, that's a great place to have your industry, right? Why not park all of your energy collecting and whatever other kinds of activity you want to do on that planet? So the idea of a service world, a world that has been co-opted for, because there's nothing living there, you can't really do any damage to it, to be used just for industry or whatever, I think it's a pretty compelling idea. And if someone built something like that, there could be signatures on that would last for a very long time. So, for example, imagine you cover half a moon in solar panels, right? Those solar panels they're going to degrade slowly, but they're not going away. And we already know from work that people have done that the reflected light off a solar panel carries a signature of the panel, right? So that there is a techno signature in reflected light off of solar panels. We call it the ultraviolet edge. So for a very long time, probably there would be, and this is a calculation that needs to be done. We're working on just the slab of metal part for that project I was telling you about, but eventually we should do the long-lived solar panel for the same reason. But that's a nice example of a techno signature that could last hundreds of millions of years, perhaps, long after the technosphere, right, the civilization that built it, was gone.
Impossible planets, so terraformers. So say we go to Mars, and over the next 10,000 years, we turn it into an Earth-like environment, if we could, if it has the materials we need, which that's in question. But we terraform Mars. We suddenly have a very unnatural planet. Astronomers out in the galaxy might say, well, that star system's about 4.5 billion years old or so. And it has a planet, Mars, in it that has an atmosphere that it should not be able to hold on to. Technosignatures in that regard, in other words, altered planets, seems like a fruitful place to look, right?
Yeah, that's a great idea. The idea that terraforming, which is large-scale planetary engineering, would be a very bright techno signature. And again, I talk about this in the book, and I talk about, okay, what do you want to do? If you ended up, your planet's a lemon, what do you need to do to make it, to turn it into that dream planet that you've always wanted? So I run through the sort of the prospects of what you have to do in terms of, right, if you don't have an atmosphere, you got to build an atmosphere, and that may require, tossing comets at it and crashing them into the surface, or doing things like pumping chlorofluorocarbons into the atmosphere, which, we know those are problematic on Earth because of the ozone, but actually they're very good greenhouse gases. So if you wanted a warmer planet, you would put CFCs into your planet. And chlorofluorocarbons we wrote a paper on this, and I talk about it in the book, that we could detect those now with telescopes, with the James Webb Space Telescope. We could detect Earth levels of chlorofluorocarbons on nearby planets orbiting nearby stars. So the terraforming becomes a great idea. And Jill Tarter, right, who is just the hero of the story of technosignatures, she was the one who suggested, if you see a solar system and you end up with like 4 worlds that all have the same temperature, the same atmospheric pressure, the same concentration of chemicals in them, then that's a really clear evidence for that they've been terraformed to they've been engineered for a particular kind of climate. She's so good. Jill is there. When we find our first biosignature or technosignature, there needs to be a statue of Jill, in front of the building, because she's just been incredible. So I think that's a great idea, right? For some number of worlds stacked in a row, all with the same climate. That's a technosignature.
You could extend it out and say nearby star systems, so clustering. In other words, you could infer that, well, they terraformed that star system, but they've also terraformed the nearest 10 star systems.
Yeah, right. That would be amazing, right? If you found a bunch of stars that were within, that were relatively close to each other, and they all had identical climates, that would also tell you.
And that that gets into unambiguous. In other words, there's not much of a way to do that without a civilization.
Exactly. Right.
And we could call it the Freon civilization because of the CFCs, the Freon planet.
The Freonians.
The Freonians. Now, looking at disequilibriums, so that's the big thing about Earth is our oxygen disequilibrium in the atmosphere, the chemical disequilibrium. And that seems to be the key to finding biospheres is when you see that weird disequilibrium of gases. And there's no clear way that could happen. But the problem is, of course, is that nature can produce most of those gases on its own, sulfur dioxide or something like that. It can make it, so you don't need a civilization. But when it all goes into disequilibrium is the question. So do we have the capability with James Webb right now to detect disequilibriums? In other words, if we put James Webb 10 light years away and looked at Earth, could we detect the oxygen and the methane and the weirdness of the atmosphere?
Yeah, actually, there was just a paper by Victoria Meadows' group in Washington that looked at Earth and looked at whether or not. And I think the answer was yes, you could see. And I'm not really sure what the limits are, but the conclusion was that the ozone, the ozone lines, the signatures of ozone and oxygen, so Earth's biosignatures would be detectable with James Webb. And I'm not sure exactly how far out you have to go, but certainly with the next generation of space time, right? With the habitable world space, because that's what it's going to be tuned for. So, disequilibrium is a really interesting thing because, like you said, that, there are, because of photochemistry, because of, light, the starlight or sunlight, you can get planets that have disequilibrium, but usually you can tell. Oh, don't worry. You can tell that if you saw it, you'd be like, oh, that's because of, photons streaming into the atmosphere. But the kinds of disequilibrium we're looking for, where life is what's driving the system, the atmospheric system out of equilibrium, there's a range of different ways to look for that. And this goes under the rubric of what we were talking about with the agnostic biosignatures or technosignatures. So, for example, Sarah Walker's group at Arizona State University has done a lot of work in thinking about networks, using not the molecules themselves, but the network of chemical reactions in the atmosphere. So, you'd look at the atmosphere, you'd see a bunch of different chemicals, and you'd look at their concentrations, and from that you could build the reaction network. Which chemical is reacting with whom and how strongly. And there is a really interesting idea that you can see a very important difference between networks that come from biology and networks that are like random. There's a very clear difference in the sort of properties, the network theory properties, like how many partners you have, how many other chemicals are you connected to. It looks very different on average for a biological network than it does for a chemical network. And that's a beautiful example of the network is reflecting the disequilibrium, meaning by disequilibrium, all we mean is that there's life and it's doing something. It's pushing the network out of where it would be if there was no life. Without it, all the chemicals reactions would kind of come to equilibrium. You'd be able to tell that nothing's going on there. But here with disequilibrium, you're driving it. You're pushing new chemicals constantly into the atmosphere, which force the whole network to rearrange. So this idea of disequilibrium for biosignatures or technosignatures, I think, is really important and really interesting. And that's a real future for us. We're not going to, as Sarah likes to say, a molecule is not a biosignature, right? And that's in response to oxygen. I still think oxygen would be great. If we find oxygen, that's going to be pretty amazing. But a molecule alone is not an unambiguous biosignature. Things like the disequilibrium, the network theory, approaches, that I think is going to give us the full context.
Life, and you coined this in your new book, The Little Book of Aliens, Life Hijacks a Planet. Where can everybody find your book?
My book is available online or wherever fine books are sold. So, Barnes & Noble or, things like that, or your local small bookshop. You should frequent those if you can.
Now, my last question for you, Adam, pertains to another one of your papers, the Salan Hypothesis. Does that idea, say there's something to the UFOs and it's there's a signal among the noise, which I think there is. a signal among the noise, and we start to unravel it. Can we ever prove a close alien actually is an alien because of the Silurian hypothesis?
Well, right. The Silurian hypothesis speaks to ancient aliens, right? So the idea there is that, look, after a couple of million years, there will be no physical evidence left over. Not fossils, because, very, very little gets fossilized. So, if you had a civilization lasting 10,000 years, which would be a long time compared to how long our technological civilization has lasted, there would be nothing left. The surface gets completely redone, and there'd be no fossil, there'd really be almost no way to tell that. So that interesting thing is, right. So for ancient aliens, no way to tell. For even present aliens, right, even if UFOs, Jacob Hockmisra makes this point of, like, let's say you do the kind of search, the kind of investigation NASA wants to do, and you build a network of instruments, and you watch the skies with them, and you find something moving at Mach 500 that just made a right-hand turn, right? Which you're like, whoa, that's incredible. What would you do next, right? So you'd be able to say, like, all right, that is moving in a way that no earthbound or terrestrial craft could operate in. And in fact, the G-forces of that are so strong that we don't even have metals that wouldn't shear, right? But that's all you have. What do you do next, right? You got to do more science, right? Because, again, they didn't land on the lawn, White House lawn. You can't shake their hands. You don't have a sample. So now you've got to build the next kinds of detectors that could go further and give you the next level of characterization. So the interesting thing is that even if we were to find evidence that UFOs or UAPs were non-terrestrial, we still just have to keep doing the kinds of science that we're doing with the other stuff too, right? Everybody thinks, like, well, that's it, we're done. It's like, no, unless you want to either shoot one down, and apparently if they're going to be this high tech, they're not going to get shot down, or they don't land on make themselves visible to us and give us samples. We're just going to have to keep doing the kind of remote sensing science that we're doing for the alien planets anyway.
All right, there will be a link to Dr. Frank's new book in the description below. And Adam, it's always a pleasure to talk to you, and I look forward to the next book. Are you going to write another one?
I will, but first, my work right now is getting to level 4 of starship design in Starfield. So that's my next goal.
I'm still trying to get past Batman. One of the Arkham Knight. I'm up against a boss, and I can't get past it.
Oh, that's the worst when that happens. You can always lower the difficulty. Kind of lame, but hey, man, if you need to do it.
No, it's very lame because I start at the lowest difficulty.
Well, then you're really shot if you can't beat it on the lowest difficulty.
Oh, man, I'm just not very good at video games, even though I love them. All right, I look forward to next time. Thanks, Adam.
Take care.